Hello everyone, thanks for tuning in. Today it's the second exam technique tip. These little hacks are nothing to do with revising or preparing for the exam. These are things that you can do while you're actually sitting in the exam that are really going to help. So yeah, let's have a look. Now there's a characteristic of exam papers that most students don't know about. Now you're probably aware that your exam paper is going to get harder as you move through the paper itself. But there are some changes which are a little bit more subtle than that. What happens is the difficulty level of each question increases as you move through that question. So question 1A is going to be the easiest, and they'll progressively get harder. 1D here will be much harder. But then what happens is the level drops back down when you start the next question. So this is the effect you get. Nice to know, but what's the relevance to you? Well, the first part of each question is going to be straightforward. If you ever get one of those questions where you think, no, it can't possibly be that simple, they can't be asking me that. Well, if it's the first part of the question, it probably is that simple. It's probably not a trick question. Let's have a look at an example of this. This is question 6.3 of an AQA physics paper. So it's the later stage of the last question, so it's going to be tricky. We've got a cell, we've got two bulbs in parallel with current I1, I2 and I3. So let's take advice from my last video on command words and highlight the command word calculate. And also underlining that bit there, write any equations that you use and give the unit. Get into the habit of highlighting your command words and any bits that might be important, and especially if you see any bold words, they're bold for a reason. They're not trying to catch you out, they're there to help you. So there we go, let's have a look at this. Now, I went in with P equals I squared R, and the reason I did this was because when I look at this, I can see 3 watts, well that's power, I can see 12 ohms, that's resistance, and I'm trying to get charge. Now I know off the top of my head that the equation I want is Q equals IT. Q is charge, I is current, and T is time. And there's a problem with that. Q equals IT, I know T, 1 minute, 60 seconds, but I do not know I. So this is a two-step process. I've first got to work out I. Okay, do I know an equation with power, current, and resistance in it? Yes, I do. P equals I squared R. So this is a question where there are 2 stages requiring 2 different equations. So if I rearrange P equals I squared R, I get I equals the square root of P over R. If you're not 100% sure or confident or need some practice on rearranging equations, then just watch my video on transposition. So P equals I squared R, rearrange it, plug the numbers in. P is 3 watts, resistance is 12, 3 over 12, square root it, and we have the current. The current is 0.5 amps. Brilliant. Now I've got the current, I can stick it into that equation that I had before, Q equals IT, charge is current times time. I just calculated that the charge is 0.5. Now I know the time is 60. Now you must use seconds. The internationally recognized unit of time is seconds, not minutes. And so you multiply them together and obviously you get 30 coulombs of charge. So that's the answer I made it to be, 30 coulombs. But I missed a mark. Can you see the word in the question that I did not pay attention to? There's a word in that question which is the reason why I missed a mark. Can you see it? The word is each. Each filament lamp. So if one of the filament lamps has 30 coulombs of charge flowing through it, and there's 2 filament lamps, then there must be 60 coulombs of charge. So knowing that this question is going to be a tricky one, it's important that you read the question very carefully. Give these questions a bit more time. Let's go back and look at question 6.1, the first of the questions. So given what I've told you, we'd expect this to be somewhat easier. So the first part of the last question should be easier than this. Here we go. A student built a circuit using filament lamps, sketched a current potential difference graph. This is an AO1 question. It's pure knowledge. No application required, nothing to work out. This is it. If you revise this, then you should know that a filament lamp has this. The more shallow the line is, the greater the potential difference that's required to push the current around. So shallow line, lots of voltage needed for a little change in current. which you should be able to work out is resistance. So shallow line, more resistance. So as the bulb heats up, as the filament heats up, the resistance increases. But you know what? That is a much easier question than the last one we looked at. So this is what it looks like. This is difficulty-wise. This is a graph of what your exam paper would look like. You might also be inclined in an exam to just skip some of the last questions. Pick up all the easier marks first and then come back to the tricky ones later on. Also, if you've just found question 2C to be very, very nasty, it's nice to know, reduces the stress if you know that the next one, or the beginning of the next question, should be much easier. So that is another exam tip. If that was any use to you, it would be really helpful if you hit the subscribe button, and I will carry on making some more little exam tip videos. And if you know anyone who would really benefit from this information, then do share it with them as well. Much appreciated to have you watching. Thank you very much, and see you again soon.